Thank you very much. It's very privileged for me to give some talk about the ocean optics and our miniature spectrometer-based Raman system. So for my topic, I have 3 parts. I want to give you some presentation about the 3 parts. The first is I will give some introduction of the ocean optics, the company. In the second part, I will show some advantage of miniature spectrometer-based Raman system. Since ocean optics is a provider and an inventor of the miniature spectrometer, and we also have more than 50 customers, OEM customers. They have made some miniature spectrometers built into their handheld Raman system, and we find that that's a trend of the Raman field. So we do some conclusion of the advantage of the miniature Raman system. And the third part, I will just show 2 or 3 applications. Those was used with our spectrometers to do some research and the result. Okay, in this slide, we just stick 2 pictures. On the left side, this is what the ocean optics began. It's in 1989. At that time, in the Mexico Bay area, the pollution is very heavy. So the United States government create a funding that who can measure the seawater pH with different depths. So the founder of ocean optics, Dr. Mac Morris, they searching for some spectrometers, but find there are no such small footprint spectrometers can be used to carry it on a boat with a fiber optic to measure the different depths, the seawater pH. So he built up a small spectrometers. That's the world's first miniature spectrometer. Because the first application was used in the ocean, so that we call the ocean optics. And from then on, many professors and students, they find that these spectrometers cannot be only used in the ocean, but can be used in different kinds of applications. For example, the germ identification or oil or some others, and also for ramen. So we start up our business with this kind of spectrometer. And just very quickly go through of our history. Just to mention, we start our business in 1989, and then to run a company called Ocean Optics in 1992. And we was acquired by UK public company called Halma in 2004. And 2 years later, we acquired a German company called Micropack, who's used to be our OEM customer, who's dedicated into the thin film metrology measurement based on a miniature spectrometer. And in last year, we have sold about 300,000 spectrometers, and we keep the leading position in the market. Okay, this is our core products. You can find the footprint just as a palm. And this is our latest, smallest spectrometers. It's just maybe like a cubit. So this is the principle of the miniature spectrometer. You can find, let's just make a sample when we measure the Raman signal. The Raman signal will go through from here, maybe connected with a Raman probe. And the scanner or relay scanner signal will be put into the spectrometer with a slit and an aperture, and then it hits to the first mirror we call the colorimeter mirror, and it reflected to a grating. The grating will disperse the light by different wavelengths and to the second mirror. The second mirror is a colorimeter mirror and will focus the different wavelengths of light then to the CCD. And then it will be a AD converter, and then to show the spectroscopy in the software. And also, Ocean Optics have some strong relationship with the Raman system, even the handheld, portable Raman system. Here I speak three parts of the Raman system. Maybe it's very famous in this field. The first is the first portable Raman spectrometer in the world. We call it R2000, which was held by Raman System Inc. And inside this system, they use just as we said before, it's a palm footprint. We call it USB 2000 plus spectrometers from Ocean Optics. And here, the second is the first commercial drugs good Raman detector. It's called Street Lab. It's also integrated some spectrometers from Ocean Optics. And this is the spectrometer we launched 2 years ago. And they use we call ROS technology, which means the raster orbiter scanner, which can make the laser, the power of the laser very weak, but use this technology and make the Raman signal very strong, which can when you make up your own Raman system, you can pick up a very small sensitivity, very lower sensitivity detector to get the Raman signal. Okay, this picture I want to show the construction of miniature spectrometer-based handheld Raman system. We call just the three big parts for a Raman system. It's a laser, light source, and a Raman probe, and then a spectrometer. Many customers they turn to us and ask us if we can support them to build their own handheld Raman system. We just provide three parts to them, and they can build up their own systems by customized software and some sampling accessories. The second part, I just want to give some conclusion as a miniature spectrometer provider. Since maybe many of the professors in their lab, we have some big desktop Raman systems, but we find that they have some trends for the Raman fields that some customers start to turn to some very small footprint spectrometers to build their own Raman system. So we do some conclusion here to show how the miniature spectrometers feature advantage and benefits in the Raman technology, and also they have some sacrifice. So we listed the trade-off here also. So we can go through it one by one. The first is if you use a miniature spectrometer, there's no moving components inside, no step motion to rotate the grating, but just use a linear CCD to collect all the wavelength signal one time. So the advantage of this spectrometer is it's very stable and durable. You can make it suitable for handheld system and carry it outside to do some online measurement of Raman. But the weakness, if we use no moving components, is that because of the limitation of the pixel from the linear detector, so the wavelength resolution is not much higher. For example, we can do a 785 excited laser with a miniature spectrometer. The resolution can be about 6 wave number. And also another advantage is we use a fiber-based probe, which means we can. It's very easy for coupling. The benefits is flexible sampling for different applications. For example, in the China mainland, there is a trend of the drug and the pharmaceutical application. They want to use Raman handheld Raman devices to measure the drugs and its main maybe some to do some differentiate for the white powder. So they prefer to use a handheld system. But if you use a fiber-based probe, you can find the repeatability is not much higher. So for sometimes when we coupling the fiber to the spectrometer and we stick it and fix it to avoid that. The third is that we use a linear CCD with a grating. So just as mentioned, if we just got one shot, we can collect the whole range, the wavelength range signal. So the measure speed should be very high, but the signal to noise ratio is not very higher than some desktop systems. So at last, I will just give some application case studies with our customers when they use the miniature spectrometers to do some results. Here is a customer in France. They use Ocean Optics Apex 532 excited laser to measure the single cell. And they can measure the RNA, DNA, protein, and lipid of a single cell with a microscope. And this research is a professor in Taiwan. They are now developing a system to measure the group B streptococcus in acid type. Can say in Chinese is 是一种链球菌，一种细菌，在人体的腹腔当中。So they use a Raman miniature Raman system to measure different kinds of how to say some material in the different kinds of the bodies and to do some differentiate. Okay. So this is my presentation. Thank you.
So, you have any comments or questions? No? Okay, so due to the